Hello there, and welcome to the Sleepy Science Stories. Tonight, we're stepping into the quiet edges of our galaxy, places where light travels for billions of years before reaching us. Hidden among these distant regions are stars older than the Milky Way itself, holding clues to the universe's first moments. But the deeper we look, the stranger the story becomes. Some stars behave in ways we can't yet explain. Some shouldn't exist at all. And tonight, we're uncovering why. So stay with me, because what we're about to discover doesn't just change our view of the sky. It challenges everything we thought we knew about the cosmos. Even the Milky Way is not as calm and permanent as it seems. Our galaxy has collided with others in the past, and it will again. What feels like a stable cosmic home is actually a tapestry woven from the remnants of countless smaller galaxies. Over billions of years, the Milky Way has drawn them in, dismantled them, and scattered their stars into sprawling tidal streams that spiral around its disk. Right now, the Sagittarius dwarf galaxy is being unraveled, while far beyond, Andromeda drifts ever closer. In roughly 4.5 billion years, these two grand spirals will merge in a cosmic dance. Though stars rarely collide, the galaxies themselves will fold and reshape, forming something vast, quiet, and entirely new. Some stars within our galaxy are even older than the Milky Way itself. Halo stars, ancient and metal-poor, travel on tilted orbits and appear to have formed in primordial galaxies that merged with ours long before our galaxy took shape. Their chemical signatures, almost devoid of heavy elements, hint at a birth shortly after the Big Bang. Floating high above the galactic plane, these stellar elders are echoes of a wilder, untamed universe, revealing a time before spirals, before order. Our solar system races around the galactic center at over 828,000 kilometers per hour, more than 230 kilometers every single second. Yet, even at this incredible speed, it takes 225 million years to complete one orbit, a journey astronomers call a galactic year. Since our solar system formed, we've circled the Milky Way only about 20 times. When the first dinosaurs roamed Earth, our solar system was in a completely different part of the galaxy. Stars are constantly on the move. Nothing remains fixed. Quietly, endlessly, the galaxy spins. Even as we sleep, the Earth turns, the Moon orbits, and the solar system sweeps onward through the living cosmos. Despite its age, the Milky Way is still growing. It draws in gas from intergalactic space, assimilates stars from captured dwarf galaxies, and weaves streams of dark matter into its halo. Growth comes both quietly as clouds fill the gaps and violently when satellite galaxies are torn apart and their stars strewn across the sky. The galaxy we inhabit today is not the same one the dinosaurs witnessed, and the one future generations will see may be far larger, stitched together from the remnants of 1,000 smaller worlds. Even now, we are unsure exactly how many spiral arms the Milky Way possesses, a cosmic mystery waiting to be solved. How many spiral arms radiate from the heart of the Milky Way? From our vantage deep within the galactic disk, the full structure is hard to discern. Thick clouds of interstellar dust obscure distant regions, while countless stars blur together, concealing the galaxy's true form. For decades, astronomers believed there were 4 main arms. More recent observations suggest a far more intricate pattern, arms that twist, split, fade into fragments, or wrap unexpectedly around the disk. The Milky Way is not a tidy pinwheel, but a dynamic, layered swirl shaped by forces we are still striving to understand. Among its stars, a few are cast adrift. While most drift calmly along their orbits, rare hypervelocity stars are flung outward at unimaginable speeds, sometimes fast enough to escape the galaxy entirely. Often, they are survivors of binary systems disrupted by the supermassive black hole at the galactic center. One star pulled in, vanishing from sight, while the other is slingshot into the void at over 1,000,000 kilometers per hour. Alone, they traverse the galactic halo like luminous comets, silent reminders that even in a galaxy bound by gravity, violent expulsions can occur. Far above the horizon, Andromeda glimmers as a faint spiral over 2 million light-years away, slowly approaching our own galaxy. In roughly 4.5 billion years, the Milky Way and Andromeda will meet. The collision will be less explosive than imagined. Stars are spaced too far apart to collide directly. Yet gravity will twist both galaxies into stretching arcs, forming tidal tails and possibly sending central black holes spiraling together. Over billions of years, the two spirals will merge into a single grand system. A slow, elegant cosmic dance, writing the future of our home across the stars. Not all stars follow the same path. While most orbit the galactic center in a shared direction, some, particularly in the outer halo, move in retrograde, orbiting against the main rotation. These stellar rebels likely hail from absorbed dwarf galaxies, their reversed motion a quiet signature of their foreign origin. The Milky Way carries the memory of countless mergers, preserved not in light, but in the patient turning of stars moving against the stream. Over billions of years, our galaxy has grown by consuming its neighbors, small companion galaxies drawn in, dismantled, and woven into the halo, disk, and stellar streams we observe today. Astronomers have uncovered the Milky Way's hidden history by studying the motion and composition of its stars. One of the most significant events, the Gaia-Enceladus merger, added countless stars and likely reshaped the early galaxy. The Milky Way is far from a pristine spiral. It is a composite, built over billions of years from quiet collisions and the remnants of countless smaller galaxies. Every star carries a chemical fingerprint, a unique pattern of elements formed at birth. Some are rich in heavy elements like iron and calcium, born in dense metal-rich regions. Others are almost pure hydrogen and helium, remnants from a universe still young.
By decoding these stellar signatures, astronomers can trace a star's origins, group stars into families, and reconstruct the hidden story of our galaxy's formation. In this way, chemistry becomes a cosmic time machine, revealing ancient histories like poetry written in starlight. Across the sky, delicate ribbons of stars stretch in arcs and curves, stellar streams, the remnants of galaxies that wandered too close and were torn apart by the Milky Way's gravity. Some form ghostly halos wrapping around the galaxy. Others plunge toward the core. These streams are living records of past mergers, threads in the grand tapestry of our galaxy's growth. The Milky Way itself is not flat. Its disk bends upward on one side and downward on the other, forming a subtle, graceful wave across the stars. Invisible to the naked eye, this warp was revealed through radio observations of hydrogen gas stretching far beyond the starlight. Satellite galaxies tug gently at the edges, and unseen clumps of dark matter bend the structure from below. Like ripples on a spinning sheet, the warp is a reminder that galaxies are never still. They bend, flex, and evolve under invisible forces, slowly dancing through the cosmos. And yet, what we see from Earth is only a fraction of this vast system. Under a dark, clear sky, far from city lights, we might glimpse a few thousand stars. To our eyes, that seems like an ocean of light, but it is barely a drop. The Milky Way contains over 100 billion stars, most hidden behind dust or too distant to see. The pale streak that stretches across moonless nights is merely the whisper of the whole galaxy, a faint glimpse of its magnificent, unseen expanse. We live within a colossal river of starlight, yet almost all of it remains hidden, too vast to perceive from our position inside the Milky Way. Stars orbit the galaxy at varying speeds. Unlike planets following tidy paths around a sun, stars move with freedom. Some race through the inner regions, while others drift slowly along the outskirts. These differences create the galaxy's spiral arms, not solid structures, but patterns akin to slow traffic jams of stars and gas. As these density waves pass, they trigger bursts of star formation, lighting the arms in brilliant curls of blue and white. Our sun rides this cosmic current, drifting in and out of the arms over eons.
The Milky Way is not a clockwork machine. It is a flowing current, and we move within it. Yet, by all logic, it should not hold together. The outer regions spin so fast that, without additional gravity, they would fling apart into the void. The unseen force keeping it intact is dark matter. Invisible, unlit, and mysterious, it outweighs all visible matter many times over, forming the scaffolding that holds the galaxy together. At the galaxy's core lies a supermassive black hole, Sagittarius A*, weighing more than 4 million suns, but confined to a region smaller than Mercury's orbit. We cannot see it directly, yet stars whip around it at incredible speeds, tracing invisible loops through the void. Occasionally, gas and dust spiral inward, flaring in X-rays before vanishing beyond the event horizon. While it rests quietly now, long ago it may have blazed like a quasar, illuminating the galaxy from within. Sagittarius A* is the silent conductor of the Milky Way, orchestrating the slow, relentless dance of stars around it. Mapping the galaxy's center revealed another surprise. The central bulge is not a smooth sphere, but a three-dimensional peanut shape. From the side, it swells in the middle and narrows at the ends like a twisting hourglass of stars.
This unusual form likely emerged from the central bar, a dense stripe of stars that rotates and buckles over time. These inner structures are sculpted by gravity, billions of years of motion, and the accumulated rhythm of stellar orbits. Though the Milky Way is a spiral galaxy, its heart is intricate, alive, and full of complexity, with stellar nurseries continually shaping the arms we see from Earth. The Milky Way's spiral arms are more than just stars. They are woven from the very cradles of stellar creation. Enormous clouds of hydrogen, dust, and molecules drift through the galaxy, and as they pass through the spiral arms, they are compressed, igniting with the light of newborn stars. These stellar nurseries are chaotic, luminous, and full of motion. Ultraviolet radiation from young stars illuminates the surrounding gas, painting the arms in radiant blues and silvers. These bursts of creation trace the spiral patterns, revealing the galaxy's curves in quiet, dazzling fire. Every star, including our Sun, began life in one of these celestial cradles. Surrounding the luminous disk lies a far more subtle structure, a vast, diffuse galactic halo. Composed of ancient stars, globular clusters, and immense amounts of dark matter, the halo is nearly invisible, but may contain the majority of the Milky Way's mass. Its stars drift in long, slow arcs, often far above or below the disk, preserving the remnants of long-ago galactic mergers. Streams and shells of stars torn from smaller galaxies linger like cosmic fossils, forming the galaxy's outer memory, a quiet, dim, yet ever-moving archive shaping the Milky Way's evolution. Within this halo are over 150 globular clusters, dense spheres of hundreds of thousands of tightly bound stars. Some are more than 12 billion years old, hosting stars that predate the Milky Way itself. Metal-poor and ancient, these clusters act as cosmic time capsules, preserving clues to how the galaxy formed, what it absorbed, and the conditions of the early universe. These glowing golden spheres drift patiently above and below the galactic plane, steadfast witnesses to the galaxy's history. The Milky Way is still growing. Despite its ancient age, it continues to gather material. Gas from the intergalactic medium, stars from captured dwarf galaxies, and streams of dark matter feeding its halo. Growth is not like a living organism, but as a gravitational structure deepening over time. Some of this expansion is quiet, through infilling clouds. Other times it is violent, as satellite galaxies are torn apart and their stars scattered across the sky. The Milky Way we see today is not the same galaxy the dinosaurs knew, and the one our distant descendants will inherit may be far larger, stitched together from the ruins of countless smaller worlds. Even within this relatively calm structure, rare stars are cast outward at astonishing speeds. Hypervelocity stars, often the remnants of disrupted binary systems near the supermassive black hole at the center of the galaxy, can be flung fast enough to escape the galaxy entirely. One star falls in, vanishing into darkness, while its companion is hurled into the void, a solitary traveler on a journey with no return. The companion star is flung outward, hurtling into the darkness at over 1 million kilometers per hour. These rogue stars travel alone, far above and below the galactic plane, like glowing comets with no return. Even in a galaxy bound by gravity, there are moments of violent release, silent expulsions that send stars soaring into the intergalactic night. Star formation within the Milky Way is slowing. Billions of years ago, the galaxy teemed with newborn stars, born from dense clouds collapsing under their own weight. Today, the process continues, but more gently. Gas remains, yet much is dispersed, heated, or locked in forms resistant to collapse. Star formation has declined since its peak, leaving the galaxy in a quieter, mature phase, a spiral in its middle age, still glowing and creating stars, but no longer in a rush. Some stars predate the Milky Way's disk. While the familiar flat spiral formed gradually, many of the galaxy's oldest stars reside in the halo or thick disk, relics from an era when the Milky Way was a loose cloud of gas, dark matter, and stars slowly collapsing inward. By studying their motions and chemical composition, astronomers can peer back to a time before structure, before spirals. These stars are the elders of the galaxy, silent witnesses to its formation and long, patient evolution.
Our sun's journey around the galactic center takes roughly 225 to 250 million years, a period known as a galactic year. In that time, continents drift, species evolve and vanish, and entire epochs unfold. Since its birth 4.6 billion years ago, the Sun has completed fewer than 25 orbits, making it a newcomer in a city of older, more traveled stars. The galaxy may appear ancient and static, but in reality, everything is in motion, and our solar system is only just beginning its long voyage through this vast cosmic metropolis. The Milky Way's rotation defies classical expectations. According to Newtonian physics, stars on the outer edges should orbit more slowly than those near the center, just as planets farther from the Sun move leisurely. Yet, in our galaxy, outer stars race almost as quickly as inner ones. The unseen culprit is dark matter, a mysterious substance forming a vast halo around the Milky Way. Invisible and enigmatic, it exerts gravity, holding the galaxy together and enabling the stars to move as if the Milky Way were a solid spinning wheel. Scattered throughout the disk are enormous molecular clouds, the raw material for new stars. Composed mainly of hydrogen molecules with traces of dust, these clouds can stretch across hundreds of light years. Within their dense, cold interiors, gravity slowly gathers matter into clumps, collapsing to form new stars and planetary systems, tiny cradles of creation shaping the galaxy, one generation at a time. Some molecular clouds are so vast and cold that they swallow visible light entirely, appearing as black voids against the starry backdrop. These are the galaxy's stellar wombs, quiet, hidden places where the future of the Milky Way begins in shadow and gas. Life emerges silently within these dark cradles, tucked away from view, yet essential to the galaxy's ongoing creation. At the other extreme, supernovae erupt with staggering power. When massive stars reach the end of their lives, they explode in cataclysmic events that can briefly outshine entire galaxies. These explosions do not merely destroy, they create. Shockwaves ripple through nearby clouds, compressing gas and triggering new star formation. Heavy elements forged in the dying star, iron, gold, and beyond, enrich the surrounding medium. Supernovae are the galaxy's storms, chaotic, radiant, and necessary, stirring and reshaping their cosmic environment. Much of the Milky Way's light remains hidden behind interstellar dust, microscopic grains of carbon, silicate, and ice that weave through space in clouds and filaments. Dust obscures vast regions in visible light, hiding stars and nebulae. Yet, behind this veil, star formation continues. Infrared telescopes reveal glittering nurseries of newborn suns. What appears dark is often a cradle. The dust absorbs energy, cools gas, and shields delicate stages of stellar birth.
Not every cloud becomes a star. Some remain cold, dark, and dormant, supported by turbulence, magnetic fields, or diffuse gas. These starless clouds drift silently through the galaxy, rich in molecular hydrogen but untouched by fusion. They may ignite someday or be torn apart, their material recycled into other regions. In them, the Milky Way holds its breath, waiting for the spark that will ignite new life. The galaxy continually recycles matter. Stars live, burn, and die, returning their material to the interstellar medium. Supernovae spread heavy elements, red giants shed their envelopes, planetary nebulae drift outward. This enriched gas cools, condenses, and eventually forms new stars, planets, and even life itself. Every atom in your body has once journeyed through this cycle, born in a star, scattered across space, and gathered anew. The Milky Way is not static. It is a living engine of creation and renewal, breathing in rhythm with its stars. Some stars are metal-poor, relics of the early universe. These ancient stars found in the halo formed when heavy elements were rare shortly after the Big Bang. Their chemical composition preserves the conditions of a primordial cosmos, allowing astronomers to peer back into a time before galaxies had fully formed. They are fossils made of light, silent witnesses to the universe's earliest chapter. Stars rarely remain where they were born. Over time, gravitational interactions, orbital resonances, and spiral arm dynamics can send stars drifting far from their natal clouds. Some are ejected at high speeds into the halo. Others migrate gradually, moving inward or outward through the disk. Even our sun has wandered from its birthplace. These wandering stars reveal a galaxy that is far from static, a Milky Way alive with motion, migration, and quiet transformation, where home for a star may be only temporary.
The Milky Way may have its own galactic habitable zone, a vast band of tens of thousands of light years where conditions are just right for life. Much like Earth orbits in the Sun's Goldilocks zone, not too hot, not too cold, the galaxy itself has regions where stars and planets can thrive. Too close to the core, and radiation and gravitational chaos make life unlikely. Too far out, and metals essential for planet formation are scarce. Between these extremes lies a stable, fertile stretch where star density is moderate and elements like carbon, oxygen, and iron abound. Earth resides here, quietly orbiting in a cosmic calm, perhaps not alone in hosting life. The spiral arms of the Milky Way are not fixed structures. They are patterns of motion, density waves that ripple slowly through the disk, compressing gas and sparking new stars as they pass. Stars drift into these arms, shine briefly, and drift out again. From a distance, the spiral pattern appears fixed and elegant, but from within, it is a shifting, living structure, never static, always flowing, held together by gravity and time. Beyond the visible stars, the galaxy hums with hidden energy. Cosmic rays, high-energy particles born in supernovae or distant galaxies, stream through space and even through our bodies. X-rays and gamma rays shimmer from dying stars and black holes, while radio waves drift from gas clouds, pulsars, and the cold breath of hydrogen. The Milky Way vibrates with a spectrum far beyond what the human eye can see, a hidden symphony of violence, magnetism, and ancient fires, echoing silently across the cosmos.
High above and below the galactic core, enormous gamma-ray bubbles stretch tens of thousands of light-years into space. Known as the Fermi bubbles, these ghostly lobes glow in gamma rays, their origins still a mystery. They may be remnants of a past outburst from the central black hole, or echoes of intense star formation that once flared through the core. Either way, they drift silently above the stars, silent witnesses to the Milky Way's unseen history, radiant reminders of violence hidden beyond the night sky. Our solar system resides in a relatively quiet corner, the Orion Spur, a minor branch nestled between the Sagittarius and Perseus arms. Unlike the galaxy's major arms, this spur is neither dense nor highly active. Here, supernovae are rarer, radiation storms less frequent, and the stellar environment is calm. It may be this tranquil corner that allowed life on Earth the time and stability to emerge and evolve. While the galaxy's outer regions blaze with drama, our small lane has offered a haven where complexity could flourish. At the center of the Milky Way lies a bar-shaped core revealed in infrared light. Far from circular, it is an elongated bridge of stars that rotates slowly, sculpting the inner spiral arms with its gravitational pull. Bars like this are common in spiral galaxies, forming as stars drift inward and accumulate along a central axis. Over time, they become stable structures, stirring gas, triggering new stars, and funneling material toward the supermassive black hole at the galaxy's heart. More than a shape, the bar is a dynamic engine, orchestrated the rhythm of the galaxy from within. Finally, our galaxy is part of something much larger, the local group, a collection of more than 50 galaxies drifting together through space. The two largest members, the Milky Way and Andromeda, are each accompanied by smaller satellite galaxies, dwarfs, faint ellipticals, and dark matter-dominated systems. Spanning more than 10 million light-years, this group is bound not by proximity alone, but by the invisible threads of gravity. Though widely spaced, these galaxies move in a slow, elegant dance, a ballet spanning millions of years. Some orbit like moons, dissolving in streams over time, while others drift independently yet remain tethered, caught in the shared pull of this cosmic community. Over billions of years, galaxies may merge, fade, or be absorbed, a gentle gathering of islands drawn together by time, inertia, and the long reach of gravity. The Milky Way's disk is layered and textured. From afar, it appears flat, but up close it reveals a thin disk and a thick disk. The thin disk, where our sun resides, is a dense, bustling plain of young stars, open clusters, and star-forming gas. Above and below lies the thick disk, older, puffier, and more diffuse. Its stars are ancient, metal-poor, and follow tilted, elliptical orbits, remnants of early galactic collisions or formation under different conditions. The disk is not uniform, it is sculpted by time, like sediment settled on the floor of a cosmic ocean. Threaded through this structure is the Milky Way's magnetic field, invisible yet pervasive. Though weak by earthly standards, it stretches across the disk, reaches into the halo, and weaves through the interstellar medium. Twisting in loops and arcs, aligning with spiral arms, it is a subtle heartbeat of the galaxy, invisible yet essential, a pulse running through its very bones. Between the stars lies the interstellar medium, far from empty. This thin, intricate web of gas, dust, and plasma forms filaments, bubbles, shock waves, and cold, dense clouds, cradles for new stars. Supernova explosions carve vast cavities, while stellar winds sculpt shapes stretching across light years. Space between stars is alive, a dynamic fabric of matter and magnetism, quietly shaping the galaxy and laying the foundations for planets and life.
High-energy particles, known as cosmic rays, pass through us constantly, born in exploding stars long ago.
Traveling mere light speed, they twist through magnetic fields, collide with clouds, and occasionally strike Earth's atmosphere, creating cascades of secondary particles. Invisible and relentless, these rays carry the story of ancient supernovae, distant acceleration, and violent cosmic events, silent messengers of the Milky Way's hidden energy. Even as we rest, the galaxy whispers, not in light, but in particles, in invisible currents flowing through every corner of space. The Milky Way is not perfectly symmetrical. Diagrams often depict a neat, even spiral, yet reality is more complex. One side of the disk is thicker. Some spiral arms are brighter, longer, or more curved than others. The outer disk warps unevenly, and star counts vary slightly between hemispheres. The galaxy is alive with asymmetry, motion, and texture, a dynamic, evolving structure that resists simplification, beautiful, intricate, and endlessly fascinating. Galactic asymmetries often tell stories of the Milky Way's turbulent past. Gravitational encounters, ancient mergers, or the subtle tug of dark matter leave imprints in its shape, scars, wrinkles, and quirks that give the galaxy character, depth, and evidence of its long, dynamic history. High above the galactic plane, drifting through the halo, astronomers have discovered a star that may rival the age of the universe itself. Virtually devoid of heavy elements, it is a relic of a time shortly after the Big Bang, formed more than 13 billion years ago, long before the Milky Way took its present form. Its soft red glow belies its significance. This star is a living time capsule, a witness to the universe's earliest dawn. The Milky Way spins like a colossal wheel, but one whose inner regions turn faster than the outskirts. Near the core, stars orbit with incredible speed, pulled by the combined mass of dense star clusters, dust, and the supermassive black hole Sagittarius A. Here, a single orbit may take only a few million years. Farther out, where our sun resides, stars trace vast loops over hundreds of millions of years. This differential rotation stretches spiral arms, twists the disk, and prevents it from behaving like a rigid structure, an elegant cosmic rhythm of motion and gravity. Spiral arms are not fixed highways of stars, but density waves, patterns moving through the disk. As gas and dust enter these waves, they compress and ignite waves of star formation, illuminating the arms with young, brilliant stars. These stars gradually drift out, while new ones form behind them, creating the illusion of permanence. From a distance, the arms appear static, yet within, they are alive, a dynamic dance of matter, rhythm, and gravity. Star formation begins in the galaxy's cold, dark arms. Massive clouds of molecular hydrogen, sometimes hundreds of light years across and just above absolute zero, slowly collapse under gravity. Dense regions form, spinning and flattening into protostars. Over millions of years, pressure and temperature ignite nuclear fusion, and a new star bursts into light. From the coldest shadows emerge the galaxy's brightest lights, crafted silently by gravity's patient hand. Many stars are born in clusters, bound together by mutual gravity. These groups drift through the galaxy for millions or billions of years, but tidal forces, stellar encounters, and internal dynamics gradually tear them apart. Stars peel away until clusters dissolve into the galactic field. Our Sun, too, once belonged to such a cluster, its siblings scattered across the Milky Way, hidden among countless others. Among the Milky Way's most ancient residents are hyper-metal-poor stars. With atmospheres almost entirely free of elements heavier than helium, some contain less than 100,000th the iron found in the Sun. Born shortly after the universe's first supernovae, they are relics of the cosmos's infancy, scattered through the halo like distant lanterns from the dawn of time. Each one is a gravitationally bound fossil, carrying whispers of a nearly forgotten epoch. Planetary systems are widespread across the galaxy. As stars ignite, rotating disks of leftover gas and dust form around them. Within these disks, particles collide and coalesce, building planets, moons, and asteroids. Across the Milky Way, planetary systems are a natural consequence of star formation, scattered like jewels throughout the spiral arms, each a potential cradle for life. The Milky Way is not just a collection of stars, it is a vast tapestry of planetary systems. Some host sprawling gas giants with frozen moons drifting in icy silence, while others are compact worlds hugging dim stars. Some resemble our own solar system, others challenge every expectation. Each system is a solar family, uniquely balanced, each orbit telling its own story, each planet a potential cradle for life. Our Sun resides near a remarkable boundary known as the co-rotation radius. Here, the average speed of stars matches the rotation of the spiral arms themselves. This subtle resonance may shield Earth from frequent crossings of dense stellar regions, reducing exposure to supernovae and gravitational disturbances. In this quiet zone, our solar system enjoys a rare stability, guided not by walls, but by the subtle choreography of the galaxy.
As it journeys around the Milky Way, the Sun does not follow a perfectly flat path. Instead, it bobs gently through the galactic plane, rising and falling over tens of millions of years like a cork adrift in a slow cosmic tide. This vertical oscillation is driven by the galaxy's gravity, a silent reminder that even on its steady orbit, our star sways softly, quietly, in time with the Milky Way. The galaxy's invisible mass far outweighs what we see. Dark matter, though unseen, dominates the Milky Way's structure. It neither emits nor absorbs light, passing through ordinary matter unnoticed, yet its gravitational influence is profound. It holds the galaxy together, dictates the rotation speeds of stars, and shapes cosmic architecture on vast scales. Without it, the Milky Way would unravel. Surrounding the luminous disk is a vast halo of dark matter, punctuated by ancient stars and globular clusters, forming the hidden backbone of the galaxy. Even the galactic core whispers of a more violent past. Today, Sagittarius A, the supermassive black hole at the center, appears calm, yet enormous gamma ray bubbles and echoes of high-energy radiation suggest that long ago it may have flared as a quasar, a brilliant beacon outshining entire galaxies. Though that blaze has faded, its remnants still stretch tens of thousands of light-years above and below the disk, ghostly signatures of a time when the Milky Way burned from within. Galaxies are never truly static. Over billions of years, the Milky Way has evolved continuously. Spiral arms shift, bars rise and dissolve, and gas flows inward and outward. Stars are born, live, and die, reshaping the stellar population. Even the disk itself, warped, rippling, and lopsided, responds to the tug of dwarf galaxies and the subtle pull of dark matter. Across cosmic time, the galaxy's silhouette drifts and morphs, a living structure, endlessly changing, yet gracefully coherent. The Milky Way of today is not the same as it was yesterday, nor will it remain the same tomorrow. Its beauty lies in quiet transformation, a galaxy constantly reshaped by forces seen and unseen. Gravitational waves ripple through the Milky Way from distant collisions. Across the universe, massive objects collide,
black holes spiral together, neutron stars crash, entire galaxies merge. These cataclysms send waves through the fabric of space-time itself. Faint, almost imperceptible, some of these waves pass through our galaxy, subtly stretching and compressing it. Observatories like LIGO and Virgo have captured glimpses of these cosmic tremors, and new experiments aim to detect the persistent hum of gravitational waves that fills the universe. Even as we sleep, space itself is moving, a quiet testament to the ever-changing cosmos. Not all stars follow neat circular orbits. Some trace elongated, tilted paths, looping far above and below the galactic plane. These stars are relics, remnants of dwarf galaxies swallowed long ago, survivors of ancient gravitational upheavals. Their orbits are three-dimensional maps tracing the Milky Way's hidden architecture and chaotic history. Like messengers from disrupted worlds, they drift across space, stretched, tilted, but still bound to the galaxy. Every second, trillions of neutrinos pass through your body, born in the hearts of stars, in supernovae, and from cosmic rays striking atoms in space. Nearly massless and almost entirely unreactive, they slip through matter unnoticed. Yet in rare collisions, deep underground or under Antarctic ice, they reveal their presence with brief flashes of light. These ghostly particles carry information from the universe's most hidden realms, the cores of stars, collapsing giants, and the Milky Way's unseen energy. They are whispers of cosmic fire. Interstellar space is not empty. It is a turbulent sea, stirred by shock waves, magnetic fields, and the motions of stars. Gas clouds collide, fold, and fragment, creating turbulence that shapes star formation, the flow of cosmic rays, and galactic evolution itself. What looks from afar like calm starlight is up close a dynamic, rippling fabric, alive with invisible winds and ancient energy. Even planets can be unmoored. Some are rogue worlds, ejected from their star systems or born in isolation, drifting cold and dark through the galaxy. Billions may roam the Milky Way silently, some in the outer halo, where stars are sparse. These orphaned planets float unseen, warmed only by their internal heat, following lonely paths through the darkness. The Milky Way's magnetic fields guide more than stars and planets. They shape the flow of interstellar dust. Tiny grains of carbon and silicate follow invisible currents, spinning, aligning, and even emitting faint microwave light. Dust dances to the Milky Way's magnetic rhythm, tracing hidden patterns in the dark and helping astronomers map the invisible structure of the galaxy. Some stars are enriched by the most violent of cosmic events. When two neutron stars spiral together and collide, they trigger a kilonova, a brief, blinding explosion forging heavy elements, gold, platinum, uranium, and more. These elements are cast into space, mixing with gas and dust, eventually forming new stars, planets, and even the ingredients for life itself.
Some stars in the Milky Way carry the chemical fingerprints of rare cataclysmic events. They are enriched with elements forged only in collisions of neutron stars, heavy metals that could not exist without such violent processes. These stars are more than luminous bodies. They are record keepers of ancient cosmic alchemy, burning with the residue of stellar wreckage. At the heart of the galaxy lies a bar of stars, an elongated bridge crossing the central bulge. But hidden deep within, astronomers have found hints of a smaller, inner bar, tilted at a different angle and rotating independently.
Obscured by dust and distance, this structure reveals itself only through the motion of nearby stars and gas. Such bars may help funnel material towards Sagittarius A star, feeding the supermassive black hole and shaping the dynamics of the core. The Milky Way's center is not a simple shape, it is a layered, shifting labyrinth of light and motion. The galaxy is not closed, it draws in fresh gas from the intergalactic medium, long, tenuous streams flowing through the cosmic web. Some arrive as cold filaments, slipping quietly into the disk. Others fall hotter, shock-heated, glowing in ultraviolet or X-ray light. These invisible rivers sustain star formation and growth, linking the Milky Way to the larger universe beyond. Even now, the galaxy drinks from distant reservoirs, nourished by threads of matter spun from the earliest cosmos. Clusters of massive stars going supernova create enormous bubbles of hot gas that punch upward through the disk and vent into the halo. These chimneys channel energy, gas, and magnetic fields out of the plane, regulating interstellar pressure, redistributing metals, and shaping halo structure. In this way, the galaxy breathes, sending towering columns of matter and energy into the dark. Though calm, invisible light, the Milky Way glows fiercely in X-rays. Collapsed stars, black holes, and hot gas in the halo emit high-energy light, invisible to our eyes. White dwarfs and neutron stars siphon matter from companions, heating it to millions of degrees. Observatories like Chandra and XMM Newton reveal a galaxy far more extreme than the tranquil spiral we see, a realm of compact remnants, intense radiation, and hidden energy. Through the galaxy, pulsars act as cosmic clocks. Born from massive stars that collapse into neutron stars, their beams sweep space with precision, sometimes hundreds of times per second. These remnants of stellar death tick steadily across epochs, used by astronomers to measure distances, test gravity, and detect gravitational waves. Across the Milky Way, pulsars keep time for the cosmos, quietly marking the rhythms of the galaxy. Much of the galaxy is invisible in ordinary light, but radio waves reveal its hidden structures. They trace cold hydrogen gas, map magnetic fields, and highlight pulsars, supernova remnants, and even distant quasars. Using arrays of radio telescopes, astronomers have mapped spiral arms, measured the disk's warp, and uncovered star-forming regions cloaked in darkness. Where light is blocked, radio waves let us see, translating the galaxy's silent language into form and shadow. Our sun, too, was likely born in a stellar cluster. Stars rarely form alone. They emerge in groups, sharing the same collapsing cloud of gas and dust. Long ago, the sun shared its cradle with hundreds, perhaps thousands of siblings. Over time, gravitational tides, passing stars, and the motions of the galaxy scattered the cluster, flinging siblings into distant orbits. Some may still shine nearby, hidden in plain sight, lost family in a sea of light. Astronomers now search for these long-lost siblings, using their age, motion, and chemical fingerprint to trace our sun's scattered family across the Milky Way. A few candidates for the sun's long-lost siblings have emerged. Stars formed from the same cloud of enriched gas may still drift through the galaxy. If identified, they could reveal the conditions in which the sun and the early solar system were born. Our place in the Milky Way is not entirely solitary. Somewhere out there, the sun's ancient kin may still shine. The galactic disk itself wobbles as it spins. It is not perfectly flat, but ripples gently, like a spinning plate nudged off balance. This warp is most visible in the outer regions, bending upward on one side and downward on the other. The cause may lie in gravitational tugs from nearby dwarf galaxies, interactions with dark matter, or internal asymmetries. This undulating motion rotates slowly, a vast wave moving through the stars. From Earth, it is imperceptible, but from afar, the Milky Way is a breathing, curving sheet of stars, never still, always in motion. Galactic tides stretch and distort star clusters and streams. Like the moon pulling tides on Earth, the Milky Way's immense mass tugs on clusters, satellite galaxies, and globular groups. Over millions of years, these forces can peel stars away, drawing out long stellar streams. Many faint arcs of stars across the sky are remnants of such encounters, clusters unraveling, galaxies slowly torn apart, patiently, strand by strand. The Milky Way's total mass remains uncertain. Stars and gas account for only a fraction. Most lies in the vast dark matter halo, invisible yet dominant. Estimates vary. Some suggest around 1 trillion solar masses, others considerably more. Measuring this is difficult, requiring precise observations of distant stars influenced by unseen matter. The Milky Way is our home, yet its true weight remains a quiet mystery.
Recent studies hint that the Milky Way may outweigh Andromeda. Though Andromeda appears larger and brighter, our galaxy's dark matter halo may be broader and denser. This could influence predictions for the eventual collision and merger of the two galaxies, shaping the dynamics of that cosmic encounter. Beneath its gentle spiral arms, the Milky Way carries more mass than we once imagined. The Magellanic Clouds, two bright satellite galaxies visible from the southern hemisphere, may be newcomers. Evidence suggests they could be on their first close orbit of the Milky Way. Their arrival has stirred the outer disk, warped the galaxy's shape, and introduced a new chapter of gravitational interaction, a reminder that the Milky Way continues to evolve. Trailing behind these dwarfs is the Magellanic Stream, a ribbon of hydrogen gas stretching hundreds of thousands of light years across the southern sky. Pulled away by tidal forces, this invisible structure reveals itself in radio wavelengths, a long, trailing whisper of motion and loss. One day, it may feed star formation in the Milky Way or settle into the halo as a delicate thread of intergalactic memory. Not everything orbits neatly in the galactic plane. Some gas clouds and stars follow polar orbits, passing above and below the disk. These misaligned paths are relics of past mergers, remnants of captured dwarf galaxies or stray clouds. They are visible records of cosmic disruption, proof that the Milky Way is not a closed system, but an evolving structure shaped by chance and gravity. Giant shells of gas mark the remnants of past starbursts. In regions where massive stars formed in rapid succession, their combined winds and supernovae carved enormous cavities, sending gas streaming outward. Hundreds of light years across, these ghostly bubbles are fossils of cosmic fireworks, echoes of intense stellar birth and death that still linger in the cold. In the densest regions, such as the cores of globular clusters, stars can occasionally collide. Space is vast, but when stars pass close enough, the encounter can be dramatic, reshaping the lives of those stars and adding new chapters to the galaxy's ongoing story. A burst of light, the merging of two suns, or the formation of a rare blue straggler star, one that appears younger than its neighbors. Collisions like these are rare, but not impossible. Over billions of years, the densest stellar neighborhoods can rearrange themselves through gravity and chance. In these crowded cosmic cities, time moves differently, and space is never quite empty. Even the most intimate stellar bonds can be broken. Many stars live as binaries, locked in gravitational embrace, orbiting one another for eons. Yet pass too close to the Milky Way's central black hole or through a dense cluster, and tidal forces can tear the pair apart. One star may be flung into a new orbit, the other captured or hurled entirely out of the galaxy, becoming a rogue star, speeding through intergalactic space. These breakups occur silently, in places we rarely
rarely see, a quiet tearing of ancient partnerships by gravity's unseen hand. Some stars escape the Milky Way entirely. Most stars are bound to the galaxy, but occasionally a star achieves escape velocity exceeding 500 kilometers per second, never to return. These hypervelocity stars are rare, yet real. Some are launched by interactions with the supermassive black hole at the core, others by chaotic encounters in triple systems or supernovae in binaries. Once free, they drift alone, tiny lighthouses beyond the spiral's edge, carrying the galaxy's memory outward as solitary pilgrims in the vast darkness between galaxies. Not all stars within the Milky Way were born here. Some are interlopers, originating in other galaxies, captured during mergers or flung into our halo from the wider local group. These intergalactic wanderers trace unusual orbits far from the disk, their chemistry and motion revealing alien origins. Like cosmic immigrants, they bring stories from other skies, other histories, enriching the Milky Way's living mosaic. The galaxy is not just a spinning disk, it breathes. High above and below the plane, gas rises and falls in the galactic fountain. Supernovae and stellar winds eject material into the halo, where it cools, condenses, and slowly rains back down over millions of years. This cycle stirs the interstellar medium, redistributes heavy elements, and regulates star formation. The Milky Way exhales and inhales, circulating matter, keeping its structure alive across immense spans of time. Even dust grains carry secrets. Within clouds of interstellar dust, scientists have detected complex organic molecules, carbon compounds that form the raw ingredients of life. Polycyclic aromatic hydrocarbons, simple sugars, alcohols, and more drift across light years, born in dying stars or cold nebula shaped by radiation. Some may have landed on the early Earth. The galaxy's dust is not mere debris, it is cargo, potential, drifting silently through the dark. Interstellar clouds may seed solar systems with life's ingredients. As planetary systems form from collapsing gas and dust, they inherit the chemical fingerprints of their parent nebula. Water, carbon compounds, and other prebiotic molecules may end up in comets, asteroids, or planets. Across the Milky Way, some regions are especially rich in these chemical seeds. Life may arise naturally, scattered far and wide, tucked into the galaxy's coldest cradles, waiting for the right conditions to grow.
Some stars spin hundreds of times faster than the sun. While most stars rotate, a few complete a full turn in mere hours. These rapid rotators, often young, massive, and unstable, bulge at the equator and may fling material into glowing circumstellar disks. The sun rotates once every 25 to 35 days, but these speed demons approach physical limits. Their lives may be brief, but while they last, they spin like sirens in the dark, a whirl of energy and motion. Finally, the galaxy itself is tilted relative to the ecliptic. From Earth, the Milky Way arcs across the night sky, a graceful band of light, yet it does not align with our solar system. The galactic plane lies tilted about 60 degrees relative to the ecliptic, the path traced by the sun and planets. This tilt is why the Milky Way rises at an angle and shifts with the seasons. We are part of the galaxy, yet our solar system drifts at a slight skew, a small tilted boat in a vast spinning sea of stars. Some stellar remnants are older than the galaxy's disk. Among the faint stars of the halo, astronomers have discovered white dwarfs, cooling cores of once luminous stars that predate the Milky Way's thin disk itself. These ancient remnants formed when the galaxy was young, before its main structure had fully settled. They have burned for billions of years, slowly fading, carrying the quiet residue of a time when the Milky Way was still gathering its shape. The disk may be bright, but the halo remembers further back.
The farthest stars orbit well beyond the main structure, tens or even hundreds of thousands of light-years from the center. These distant halo stars move along slow, sweeping paths, taking billions of years to complete a single orbit. Many were likely captured from smaller galaxies in past mergers, now drifting in the outermost reaches like silent sentinels. Sparse and faint, they help define the Milky Way's size, shape, and gravitational influence. The galaxy is far more than what we see. It extends deep into the dark, shaped by wanderers at its edge. The Milky Way's shape is subtly lopsided. Though often depicted as a perfect spiral, the galaxy is irregular. One side of the disk is thicker, the spiral arms vary in brightness and length, and even the stellar halo is slightly off-center. These asymmetries likely arise from gravitational interactions with the Magellanic Clouds, dark matter clumps, or past mergers. The Milky Way is not a precise pinwheel. It is a living structure marked by tugs and twists, a spinning dancer whose skirt has been caught by the wind. Its beauty lies in that irregularity, a graceful imbalance sculpted by time. Astronomers map the galaxy using variable stars. Certain stars pulse in brightness over regular intervals, expanding and contracting like slow, luminous heartbeats. Cepheids and RR Lyrae stars in particular have well-known relationships between pulse period and intrinsic luminosity. By comparing their true brightness to how bright they appear, astronomers can measure distance. These stars act as cosmic yardsticks, tracing the Milky Way's shape, structure, and scale, lights that measure the dark corridors of the spiral. The Gaia mission is revolutionizing our understanding. Launched by the European Space Agency, Gaia is crafting the most precise three-dimensional map of the Milky Way ever made, measuring positions, motions, and brightness of over 2 billion stars. Gaia has unveiled streams from shredded galaxies, mapped the warp of the disk, and traced the sun's orbit with exquisite detail. Each data release sharpens our view, turning a hazy smear of stars into a living, breathing map. It is astronomy's quiet revolution unfolding among the stars. The galactic plane marks the dense heart of the Milky Way. On a dark, moonless night, away from city lights, the Milky Way appears as a hazy river of starlight. This is the galactic plane, the vast, flattened band where most stars reside. Along this corridor, stars are densely packed, dust is layered, and star formation is ongoing. From our vantage point, we look along the grain of the galaxy, peering through its richest, most crowded corridors. This luminous band is not just beautiful, it is the humming heart of stellar life and death. Toward the galactic center, the night sky shines brightest, drawing the eye to the densest, most energetic region of the Milky Way, where stars, dust, and gas converge in a vast, dynamic heart. The core of the Milky Way lies in the direction of the constellation Sagittarius, a dense, glowing concentration of stars, dust, and unseen mass. From Earth, we cannot see its very heart in visible light. Clouds of dust obscure the view. Yet, in infrared and radio, it glows brightly, a crowded city of billions of overlapping stars. We orbit far from this center, in a quiet suburb of the galactic disk, but when we look inward, we glimpse the galaxy's bustling heart. We see the Milky Way from within. Because we live inside it, we cannot gaze down from above. Instead, it stretches across the sky as a flat ribbon of stars, curved only by the horizon. This inside view compresses the galaxy into a single arc, hiding its full spiral grandeur. For centuries, astronomers cataloged, measured, and calculated, slowly revealing the spiral we call home. Looking through the disk is like standing in a forest, peering along the line of the trees. We sense the vastness, but not the full shape. The Milky Way contains far more than we can see. Even with our most sensitive instruments, we glimpse only a fraction of its mass and motion. Dust blocks light, dark matter outweighs luminous stars, and between every star lies emptiness brimming with potential. The galaxy is not just what we see, it is what we infer, what we imagine, what we strive to understand. It holds ancient light, future stars, drifting worlds, and mysteries yet unsolved. And within this vastness, somehow, we exist. One planet among billions, orbiting a quiet star, floating through a story too immense to grasp fully. The iron in your blood was forged in long-dead stars. The oxygen you breathe was sculpted in ancient supernovae. The atoms of your body trace their lineage to the earliest cosmic times, born from the same matter that now fuels suns and whispers through clouds of interstellar dust. Tonight, as you rest, the galaxy turns on. Stars are forming, light is traveling, orbits continue silently, and you are part of it, a small warmth in the dark, resting in the spiral arm of a quiet, radiant sea. If you are still awake, you may watch the next chapter unfold. Otherwise, sleep well and dream softly. Good night.